Our next topic, B.3, average case efficiency of binary search. And let me use n equals 7 to show you the answer. So what is the answer? Okay, all right. Here, let's look at this example, n equals 7. First, n equals to 7, what is the worst case? Based on our formula, worst case. Okay, 1 plus floor function log base 2 of 7. This is the formula. 1 plus 2, right? Yeah, log base 2 of 7, 2 something, less than 3. Yeah. Log base 2 of 8, that's 3. Log base 2 of 7, less than 8, strictly less than 8. So 2 point something. Then the floor function is 2. 1 plus 2, that's 3. Okay, yeah, that's the worst case. The average case should be smaller than 3. Yeah. But how close to 3? Yeah. So let's look at how close to 3. Yeah. All right, so let me show you how to find the average. All right. Data, 7 elements sorted array. Yeah, like this. Yeah. Here I draw diagram. Yeah. Then we run the binary search, and when we consider all the possible cases, 7 cases, then we can draw a binary tree. The binary tree to represent all 7 cases here. Okay, yeah. Yeah. All right, here we make a simple assumption. V is in the array. Yeah, V is in the array. Yeah. If V is not in the array, then we need to do another assumption, the probability. Some probability P for which V is in the array. Yeah. Here, to make the discussion as simple as possible, let's make this assumption, V is in the array. All right, yeah. So then let's consider, yeah, right, yeah. So the P, yeah, you need to use that P. Now let's consider the first comparison based on the binary search. We need to compare V with element at position 4, right? Yeah, absolute middle location. That's our first comparison. Compare it with element with position 4. Yeah, position number 4. Yeah, that's our first comparison. Okay, then we need to go to the left branch or right branch based on the comparison result, greater than or less than. Okay, all right, so we have 2 branches. Yeah. For the left branch, we have 3 elements in the left branch, but the second comparison, we need to compare V with element at position 2. So we put this node as the root of the left branch. Similarly, element with position number 6 should be at the root of the right branch, because that's the one we need to do the second comparison. Yeah. So these two elements, we need 2 comparisons to get a match. Okay. Then going down, yeah, another left-right consideration. So 1 at the left of node 2, and 3 at the right node of 2, and so on. Okay, yeah. So this is our final binary tree representing the comparison situation for this 7-element sorted array, ordered array. Okay, yeah. And the third comparison, the bottom 4 elements require 3 comparisons. Now, after we collect information in this binary tree, then we can write our average formula. When we take the average, we need to consider average of all these 7 cases. Average, 7 cases, yeah. And you need to factor in the number of comparisons for 3 different levels, right? Yeah, there are 3 different levels. The top level, only 1 comparison needed. And for the elements in the second level, 2 comparisons needed. And the elements at the bottom level, 3 comparisons needed. All right, yeah. Based on that, let us write the average number of comparisons for these 7 cases in this way. Yeah, this way, average. Okay, yeah. Because only 1 element in the top level. For 1 comparison, there is only 1 element. Right? For 2 comparisons, there are 2 elements. So 2 times 2. Total number of comparisons. Subtotal, yeah, that's the subtotal. So for top level, the subtotal number of comparisons, 1 times 1. For second level, the subtotal number of comparisons, 2 times 2. Okay, because there are 2 nodes, and each one requires 2 comparisons. So 2 times 2. For the bottom level, each one, the bottom one, yeah, so here, yeah, probably my arrow is wrong, all right? Yeah, I got confused, all right? Yeah, so for, oh, that's correct, right? Yeah, okay, yeah, my arrow is correct, okay, yeah. So the bottom one, each one requires 3 comparisons, but we have 4, okay? The number of nodes at the bottom level, there are 4. And each one, 3 comparisons. The subtotal, 3 times 4. All right? Then the total, you add up. These 3 subtotals, you add them up. That's the total. Then you divide it by 7. There are 7 cases. So the average number of comparisons, 17 over 7. 17 over 7. Yeah. So if you write this mixed version, 2 and 3/7. 2 and 3/7. Yeah. Here you may argue this number is not very close to 3. Yeah. But when n is large, when n becomes larger and larger, the average larger and larger, then your average case is closer and closer to the worst case. Yeah. Okay. But the difference is less than 1. The worst case and the average case, the difference is always less than 1. So you can see how close they are. Less than 1 difference, how close they are when n is n, for any n number. Yeah. Yeah. That is the way we calculate the average case. Think about that. Okay? Yeah. Can you do this? Yeah. In this assignment, I didn't give you this question calculating average for the binary search. I didn't give you this kind of questions. Yeah. But later, sometime, yeah, I may need to give you this kind of questions. Yeah. So you need to understand this example. Okay? Yeah. And later, when I give you questions, I may not give you power of 2 minus 1. So here I give you power of 2 to the k minus 1. Yeah. Because this is the easiest case for you to do the calculation. Yeah. Later, I can give you, arbitrary positive integer number and ask you to do the calculation. Okay? Yeah. All right. Yeah.